Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. Okay. As usual, we first come to its statement. Okay. A beam of 8.0 million electron volt alpha particles scatters from a thin gold foil. What is the ratio of the number of alpha particles scattered to angles greater than 1 degree to the number scattered to angles greater than 2 degree? Okay. Ratio of the number of alpha particles scattered to angles greater than 1 degree to the number scattered to angles greater than 2 degree. Okay, 1 degree and 2 degree. Dear students, actually solution of this problem is quite simple and easy, but we must know the philosophy behind the solution of this problem. Okay, actually the problem is of such nature that most of the parameters are cancelled and we are to deal only with the angle. Okay, on the basis of this angle this ratio can be determined. Okay, but definitely we need to know everything. Okay, dear students, before starting its solution in a proper manner, we go through a slide, okay, which will enable us to understand the problem in a relatively better manner. Okay, actually dear students, there are two snapshots, but actually they are alternative of each other. Okay, basic philosophy behind both these is same. The only difference is that these two snapshots have been chosen from two different books, and authors of those books have expressed this philosophy in accordance with their own style or discretion. Okay, for example, dear students, the difference between these two snapshots regarding just pattern is that in first slide small z and capital Z have been used, while in its alternate second snapshot small q alpha and capital Q are used. Okay, no dear students, these two are used in place of E square. Okay, in first snapshot E square has been used, electronic charge, elementary charge, charge of an electron. Okay, but here in place of E square small q alpha and capital Q have been used. Okay, moreover, in the first snapshot in place kinetic energy is denoted by capital K, while in second snapshot kinetic energy is denoted by mv square, where m is mass of alpha particle and alpha is written as a subscript of m. Okay, similarly in the first snapshot 1 over 4 pi epsilon naught is written as it is, but because this constant has an other name and sometimes it is denoted by small k, so in second snapshot this factor is replaced by small k. Okay, Okay, dear students, in first snapshot, K is capital and it denotes kinetic energy, while in second snapshot, K is small and it does not denote kinetic energy, it denotes 1 over 4 by epsilon naught. Okay, anyhow, we go through these snapshots shortly and then we solve our problem. Okay, first snapshot says scattering impact parameter B is equal to Z small z capital Z. This small z capital Z can also be denoted by Z1 Z2. Okay, in various books in instead of a small z and capital Z, these are denoted by Z1 Z2. Okay, so it does not make any difference. Okay, scattering impact parameter small b is equal to small z capital Z over 2 into capital K, that is kinetic energy, into E square over 4 pi epsilon naught into cot 1 by 2 theta or cot theta by 2. Okay, next it is explained that fraction scattered at angles greater than theta denoted by f greater than theta, where symbol greater than theta is written as a subscript of f, is equal to n t pi and b square. Here b is the exactly same which is shown above as being equal to small z capital Z over 2k into E square over 4 pi epsilon naught into cot theta by 2. Okay, so it means while determining fraction we will put the value of b from first expression into second expression. Okay, dear students, now we come to second snapshot, which is just a reproduction of the first snapshot, but because two different books are involved and two different authors are involved, their methodology is slightly different. Okay, now we come towards the second snapshot. In this snapshot, Rutherford scattering impact parameter. Okay, Rutherford scattering impact parameter B is equal to small q alpha, where alpha is written as a subscript of q, into capital Q divided by m alpha, where alpha is written as a subscript of small m, into v square into cot theta by 2. Okay, scattered fraction f small f is equal to pi b square nt for a scattering foil with n nuclei per unit volume and thickness T. Okay, T is thickness while T is thickness while n is nuclei per unit volume and B is impact parameter. Anyhow, dear students, now we start our solution in a proper manner, in a formal manner. Okay, we summarize above two snapshots in our own wording in this sense. Okay, we say that the relation between the impact parameter B and scattering angle theta for Coulomb scattering is small b is equal to Z1 Z2 into E square over 8 pi epsilon naught capital K into cot theta by 2, equation number 1. Okay, in snapshots small z capital Z or small q and capital Q were used, small q capital Q were used in place of E square, and similarly in in place of Z1 Z2 small z and capital Z were used. Okay. Now, dear students, we move a step ahead. Now we come towards the fraction. Now, scattered fraction small f for a scattering foil with small n nuclei per unit volume and thickness T is given by small f equal to pi into b square into n into t, equation number 2. Okay, by using equation number 1 in equation number 2 we have, okay, what we have done, we have just put the value of b from equation number 1 in equation number 2. Okay, then f will become, f is equal to pi nt into z1 z2 e square z1 z2 e square over 8 pi epsilon naught k. Okay, yes students, I think this should be square. This is a minor mistake. Okay, here this is a minor mistake. Actually, when we will put value of b here, then because b is equal to this, so here when b square will be used, so its square will be used. Okay, so to the extent of cot square theta by 2 is quite okay, but here z1 z2 into e square over 8 pi epsilon naught k, this should be square. Okay, so please assume it to be square. This is by mistake, square has been omitted. Okay, f becomes equal to pi and t into this factor whole square into cot square theta by 2, because in equation number 2 we are using equation number 1 and b is in square. Okay, so this factor will also be in square. This is a minor mistake. Okay, f becomes equal to this into this square into cot square theta by 2, equation number 3. Hence, from here, in from equation number 3, f1 degree will take this form and f2 degree will take this form. Okay, f1 degree here, in place of theta we will use 1 and we will get 0.5. Okay, because 1 by 2 is equal to 0.5, and when we will put 2 degree, then 2 divided by 2 we will get 1. Okay, so in the next step we will find the dear students, now actually we will divide one f1 degree by f2 degree. When we will divide, then all such factors will be cancelled. Okay, pi and t will be cancelled. Similarly, z1 z2 e square over 8 pi epsilon naught capital K whole square, this will also be cancelled, and we will be left only with the cot square 1 by 2 degree or 0.5 degree divided by cot square 1 degree. Okay, so in this way we will get now f1 degree over f2 degree is equal to cot square 0.5 degree divided by cot square 1 degree. This becomes equal to this over this. Okay, meaning cot 0.5 is equal to 114.59, and it will be in square because cot is square, cot square 0.5 degree. Similarly, value of cot 1 degree is 57.29, and it will also be square because both cot in the numerator and denominator are square. Okay, actually dear students, I have taken this value of cot 0.5 from online trigonometric converter. Okay, you may take this value from some other source. Okay, there may be a lot of ways to find such values. Okay, anyhow, I have used um, quick and most easily available method, that is from internet online converter. Okay, so just we have put these values, and then this becomes equal to this, and this becomes equal to this, and when this will be solved, we get fraction equal to 4.1, 4.0. Okay, our answer, that is fraction of scattering angle at 1 degree and 2 degree, finally becomes equal to 4.0. And this is the end of our problem. This is the end of our video. Till next video. Allah Hafiz.